Hello and welcome. The chapter which we are here to discuss is measurement and motion. So when we are dealing with measurement, first of all, what is the need of measurement? Suppose you went to purchase a piece of cloth and you ask the shopkeeper, please give me a piece of cloth. So if there is no measurement, then how will he know how much piece he has to give you? If you are purchasing vegetables from a shopkeeper, how will you manage to know that how much quantity of vegetables you have to purchase and how much you have to pay? So measurement is necessary. Measurement is extremely necessary. So what we do is, first is need for standard. The first topic is need for standard unit. Need for standard unit. So need for standard unit. There should be a standard which has to be there while calculating or while measuring. So why it is important to have this thing is, when we suppose if I ask someone to measure this board, so if I am measuring this board, the length of this board with my this span of my hand, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then some part is lost. So now after my measurement, if I ask any one of you to do this measurement, would it be possible for you to do it? No, quite not, because the size of your hand will vary. The size of my hand is not same as size of yours. And if someone is having a size of hand much larger than me, then what? In a similar way, we wanted to have a fixed unit of measurement. To measure things, we needed a fixed length or fixed things which can be easily used or reused again and again. That's why we had this system. Need for standard units. Standard units means meter, kilometer, gram, centimeter. They are for millimeter. These are standard units which are very much helpful in measurement. So that all can have the same or similar measurement. For example, if a tailor is making a suit in India and a similar one is making same thing in America, and both are not using the same measuring tape. One is telling that I am making it in centimeter, and one is using the same. Suppose Indian one said that I am using the length of cloth as 50 inches, and the one in America, he thought that okay, he is using 50. He's using 50 centimeter. Are they both same? No. So that is the reason standard unit should be same. Okay, that is the whole concept behind this. Okay, so what happens here according to book? Need for standard measurement. In older times, people used arm length, footsteps, foot span, yard, handspan, cubit, fathom, etc. for measuring length of an object or distance between two places. However, these measurements lead to inconsistent results, as everyone's body part could be slightly different different size. So, standard units of measurement. In order to measure different physical quantities accurately, scientists all over the world accepted a set of standard units of measurement known as System International D units or SI units. Another Latin term is Systemic International. It's Latin. Systemic International. So, SI units, which stands for international. These units are international, made so that the things which are inside it will remain same. 1 kilometer will have 1000 meter. In India also and America also, 1 kilometer will have 1000 meter. So things are similar everywhere. In length, SI unit is meter, while in CGS it is centimeter, in MKS it is meter, in FPS it is foot. Mass, kilogram, gram, kilogram and pound. Those who go to gym, they are you can ask them that they say how much pound you are using, how much weight of how much pound you are using. So the pound is a unit. Okay, so similarly time. Okay, one thing is similar to time everywhere, that seconds for every systems, be it CGS, be it FPS or be it MKS. So CGS stand for centimeter, gram, second. MKS stand for meter, kilogram, second, and FPS stand, full form of FPS is foot, pound, second. So measuring length. Length is the measure of the distance between two different points. SI unit of length is meter. We also use some similar units of measuring length. Simple. I give you a line. I ask you to draw a line of 5 centimeter. So it's quite simple for you. You will use a scale or ruler. You will strike a line of 5 centimeter. That's it. It's done. You are able to measure it because you are using a scale to do it. That is the whole thing which they are calculating in this topic. Now things are what are the units which are there. For example, look at your scale. If you are having in your scale, you will find 1 centimeter have 10 millimeter. Similarly, 1 meter has 100 centimeter. Okay, 1 kilometer has 1000 meter. So 1 inch has 2.54 centimeter and 1 foot has 12 inches. So these are the relationships of the different units. These are the relationship between different units which are there. So things doesn't get complicated. For example, suppose if I have to go from Bhadugarh to TP borders, if I have to go from Bhadugarh to TP border and I have to calculate the distance, I can't calculate this distance not in meter, not in centimeter, definitely not, and not in millimeter, definitely not. What I can do here is I can calculate it in kilometer, and afterwards if someone asks me how many meters are there from Bhadugarh to TP border, I can simply convert it into meter and tell you. Okay, so these are the unit conversions which we need. Okay, now devices to measure length. So what we have done till now is lead for steps and measuring length, standard units. Now next is measuring length. So when you want to measure things length, you use different things to measure length. For example, when you are measuring a simple length, you can use rulers, or simply call them by the scales or foot. I don't know why you call that, but rulers, scales. So you can use it. You just draw a line. You just take the scale, and you will be able to understand that where the line is ending. You can take out the measurement of it. Similarly, metal rod. 1 meter rod, it is at the cloth shops. Every cloth shop has it, where they use this metal rod to check the length of the cloth. Okay. Then last is tape. Suppose you visited a tailor, and now the tailor wanted to have size of your wrist or size of your stomach or waist. Now what he will do? He will use a scale, and he will use that scale. Okay, 6 centimeter, or he will use a meter scale. And बोल घुमाते हैं जी ऐसे हो गया. No, quite not possible, because that thing can't bend. Okay, that thing can't bend. So in order to bend things, why not to use something which can't be bended? So it's a measuring tape. Measuring tape, you will just rotate it around and you will be able to measure it. If there is anything which is having multiple, not a single straight line, if it is having curves, you can measure it very easily using a measuring tape. Okay, so that is the reason we don't rely on only one thing. We have 3 types of methods which can be used nowadays. The recent one is the laser method. You don't need to points, but that will happen in the straight line, not in the curved path. Measuring length using a ruler. Now you know that how to measure the length, how to do the thing. So topic on page number 135 and topic on page number 136, measuring the length of a curved line. These two topics have to be done by you. These two topics have to be done by you, because you know how to measure things using a scale. You know very clearly that how to use a scale and how to check the correct place that you are accurately getting the values. Okay. So after this, the next is importance of estimation. Okay. What is estimation? So basically, when we are talking about estimation, estimation simply means rough estimate or guessing something. Suppose you want to make a sandwich. So for sandwich, you will estimate that I have to make sandwich for my family. So I need at least 4 or 5 or 10 or so 20 slices of breads. Then after that, you need to have I need to have whatever cheese or whatever. I will need this much amount of cheese or butter to have make it or patties or whatever you are doing. You need to have a rough estimate of it. Okay, without estimate you can't imagine anything to be happen in the ground reality. So that is the thing this estimation is all about. Okay. Now next is motion. The next topic which we have is motion. When anything is moving, if I throw a ball, that ball will start moving. Previously it was at rest, now it is moving. It is having a motion. A bus started moving. It is now in motion. Human started running. It is having a motion. Whatever thing which is moving from one place to another is having motion. Whatever it is moving from one place to another, it have motion. That's all. Now the question is, rest and motion are related. Rest and motion are related because there are multiple times. Suppose you are sitting inside a bus and you watch trees outside, and when the bus started moving, it felt like trees are passing by. Trees are moving. But if someone is standing at the tree, it will find you to be moving. I will explain this thing. Suppose you are sitting inside a bus or a train, and now the train or bus started moving. So all of the stationary objects, now train is moving. This is the train which is moving, but the tree, whatever the tree it is it moving? Can tree run? No, it can't move. So tree is stationary, but the bus is moving. So according to bus, tree is moving. According to the person who is sitting inside bus, tree is moving. And according to the person who is standing in tree, that bus is moving. That is the reason we call rest and motion are related. It has to be very carefully observed that who is moving and who is at stationary position. Okay. So when we are dealing with motion, then we have few types of motion. First is translatory motion. Translatory motion means simply from one place you are covering one place, from starting from one place and ending at one place. That is translatory motion. The better explained part here is rectilinear and curvilinear motion. Rectilinear means motion in a straight line. I should rub it off. Something started from here and ended from at here. A leaf from tree fell. So they will always have a straight direction. Okay. If I am throwing an arrow, javelin, if I am using a throwing an arrow, so firing an arrow, suppose they will move in a straight direction. Okay. So or straight path. It can't happen like it happens in the south movies that they fire They will go in a straight direction in a single turn. So that is the thing which is happen. So such type of motion where straight line is straight path is called rectilinear motion or linear motion. Next is curvilinear motion. Suppose this is a mountain. Okay. Road was moving around this way. On mountain, it's very common for roads to turn like this. So whatever thing which is now moving from here at this portion will have curvilinear motion. Okay. Next is rotational motion. When an object moves around a fixed point, it is said to be in rotational motion. In this type of motion, the different parts of object move different directions in the same given time. For example, in a rotating fan, the outer portion of the blade will make a bigger circle than the inner portion of the blade. Rotation motion something is have you whenever you have visited any that place amusement park, there merry-go-round or there are something some seem like you can say rides are there. What happens is generally when you sit on them, this is the box where they ask you to sit, and when they start moving, what happens? Previously it was at this position, now they will, because of the motion, they will move on, and now they will reach here. So previously position was this, now current position is this. So this type of motion they are talking about, rotational motion. Now this will be at the same position where it was, but this will be able to move and it will be able to cover the outer part of it. Okay, that is the thing which we are talking about. Next is repetitive motion. Repetitive motion is something which is repeating again and again. For example, ball clock 12, 3, 6, 9. Hands are moving round and round and round and round. Okay, and they are moving periodically. Okay, so in repetitive motion we have two types, that is periodic and non-periodic. They are periodically moving. Okay, now look at my eyelash. They are moving periodically, but are they moving in a proper time? I can stop that movement also. I don't want to move it now. So what is happening here? It is periodic motion, but it is happening non-periodically. When I want, I am using it, closing my eyes. Okay, but in clock, it can't happen by itself, or it happens by itself, but it can't stop by itself. Okay, so it is moving in a periodic manner. Okay, every minute it is moving. This minute hand is every minute moving. Our hand is every time moving. So they will show movements on a periodic manner. Next is oscillatory motion. Oscillatory motion, like those jhulas which you hang on tree branches, they go on like this and that motion. They have a peak point, then again they come to the middle point, and then again they have a peak point. Tree branches, or those jhulas on tree branches, or a pendulum from a, if you tie a ball with a rope and you just leave it and make it move. So this thing will happen. Okay, so such motions are called oscillatory motions, where they show the oscillations. Next is random motion. Random motion means nothing which can be repeated again. We can't be sure that it will be getting here. I was sure that if it is going here, it will definitely come back here, and then it will definitely. So I have 3 points: A, B, and C. If it is at B, it will definitely come to A, and if it is at C, it will again definitely come to A. But in random motion, I can't be definite that it will either come to A or not. Okay, suppose a bird is flying. Can you say that bird will come back to its this position now again? We can't say this. When an object changes in direction in an irregular manner while moving, it is said to be random motion. Movement of a bee and a flying handle of the machine, it goes in a circular motion only. No matter how fast or how slow I go or even that I go, it will always go up and down only. Now उल्टा भी चलाऊंगा